Hey, 7th grade, this is lesson 97. We're talking about similar triangles and indirect measurement. So first off, we need to talk about what does similar mean. We've learned the word already about congruent. Congruent is when shapes are exactly the same size. So this triangle right here and this triangle right here, they're exactly the same size and the same shape. So we call these ones congruent triangles. But this one here and this one here are the same shape, but they're not necessarily the same size. So that means we would call these similar to each other. So this triangle is similar to this triangle. So let's talk about corresponding angles. So let's just go ahead and start with B. I think that one looks like the most obvious one to tell. Looks like kind of the biggest angle there. If B is the biggest angle here, what's the biggest angle over here? It looks to me like X. So what I'm going to do is I'm going to say angle B and angle X. Those are corresponding sides. I'm going to say this one is the same as this one. And then I'm going to go with the smallest one now. Looks like C up here is the smallest one. So I'm going to look down here. Which one's the smallest one of these? Well, looks like Y is the smallest. So I'm going to say C is the same thing as Y. So angle C and angle Y. Well, and if B is the same thing as X and C is the same thing as Y, that means A is going to be the same thing as Z, kind of the middle one. Angle A and angle Z. So notice those angles are congruent to each other. This one's the same measure as this one, this one's the same as this one, that one's the same as that one. So these are what we call corresponding angles. Corresponding sides are the sides that correspond to each other. And we can kind of use this information we already have. Notice this side AB goes from the one with 3 marks on it to the one with 1. So the corresponding side would be the same over here, 3 to 1. So I'm going to say AB and ZX. Notice here, if I'm going to say AB, I went from 3 to 1. I'm going to do the same thing, 3 to 1, ZX. Let's see, BC. And then the corresponding side over here went from 1 to 2. So from 1 to 2 would be XY. And then lastly, AC, the air conditioner. From 3 to 2 would be the same thing as ZY. Those are our corresponding sides. Now this next thing is very important. This is like the whole purpose of the lesson, or what we're learning about today. The length of corresponding sides of similar triangles are proportional to each other. So proportional means, well, remember we can set up, means two ratios that are equal to each other, or two fractions that are equal to each other as a proportion. So if I said this length over this length, the corresponding side, it'd be the same thing as this length over this length, and the same thing as this length over this length. So those are corresponding and they are proportional to each other. So here's one that we're going to be using indirect measurement, which is the other thing. I guess before we do that, let's talk about direct measurement. Direct measurement is to say how wide is the table that you're working at. You just grab a measuring tape and you directly measure that object because it's not hard to do. Right? If you want to measure how tall you are, you just back up next to a wall, put a mark, and measure it. But there's some things that are really hard to measure, say like a tree or a building or a giraffe, because you can't just grab a measuring tape, run up to the top of it, and measure it in most cases. So that makes it a little bit harder to measure. So what we do is we use the fact that at the same time of day, the sun casts parallel lines, or it makes similar triangles with the shadow and the objects. This is one way to use that. So let's go ahead and read this, and then we'll draw a picture to go with it. It says, to indirectly measure the height of a telephone pole on the playground, some students measured the length of the shadow cast by the pole. The shadow measured 24 feet. The length of the shadow cast by a vertical meter stick was 40 centimeters. About how tall was a telephone pole? So here's a telephone pole. Perfect. And it has a shadow. Okay? So, and its shadow is 24 feet. And we would like to know how tall it is. Well, to do that, they stuck a meter stick in the ground. That's the meter stick. And they found its shadow length to be 40 centimeters. So this is 1 meter tall. But since we have this measurement over here in centimeters, we want to talk about the height in centimeters, so they're the same. So that's going to be 100 centimeters. Now the sun casts is what's making those shadows, right? And so since it's at the same time of day, these two triangles are similar to each other. This is approximately a right angle. This angle will be the same as this one, okay? So we can see if we can set up a proportion here. So we can say 40 over 100 should equal to, remember the 40 is the shadow length, so the shadow length over height is going to equal to the shadow length over height. So it's going to be 24 over, I'll call it x. So cross multiplying here, 40x is equal to 2400. And then I'm going to go ahead and divide by 40. 40 divided by 40 is 0. That x is the height that I'm looking for. 10 goes into both of those, and then 24 divided by 4 would be 1260. So the height is about 60 feet. Since this is all said in abouts, right? About. So we're going to say about 60 feet. Here's another one. It says Brad saw that his shadow was the length of about 1 big step or 3 feet. So here's Brad. I know I'm an awesome artist. Here's his shadow. It's 3 feet. He then walked along the shadow of a nearby flagpole. Bum, ba, bum, bum. Nearby flagpole and found it was 8 big steps. So each one is 3, so 8 and 8, 16, 24. So its shadow length is 24 feet. Right? 8 big steps. Each big step is 3. So 3 times 8, 24 feet. Brad is about 5 feet tall. 5 feet is his approximate height. Which is the best choice for the height of the flagpole? So we're looking for this height. So cool, let's go ahead and do something similar here. So 3 over 5. Again, I went shadow length over height. So I'm going to go shadow length over height over here. Shadow length over height. I'll just call it h. And then let's solve. It's going to be 3h is going to equal to 120 dividing by 3. H is equal to 40 feet. So again, I'm going to say about 40 feet high. So the answer would be C. All right, guys, if you have any questions, let me know. I would love to help you out. All I have to do is ask. Good luck, guys.